Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So today we will continue our lesson on embedded system, okay, chapter 2, which is about ATmega 328. Right, so ATmega 328 is actually one of the microcontroller, okay, which is being introduced by Atmel, and this is some of the features of ATmega 328. Right, so for the first feature, it has 32 kilobytes of ISP flash program memory. So they have a cycle of write and erase of 10,000. Alright, and then they have 2 kilobytes of internal static RAM. They have 1024 bytes of EEPROM. So in the previous class, you have learned about SRAM and also EEPROM. Right, so for EEPROM, they have the write and erase cycles of 100,000. Alright, and then next they have the JTAG programming or debugging interface, and then they have 6-channel 10-bit ADCs, and then they have 2 units of 8-bit timer or counters and 1 16-bit timer counters. All right, so this is for clock, and also you wanted to do some delays, some timing, and so on. All right, so they also have 6 PWM channels. So in terms of communication, serial communications, they have used the USART, SPI, and I2C interface. And then in terms of watchdog timer, analog comparator, reset, brownout detection, internal RC oscillator, power save modes. Right, actually the watchdog timer is a specialized timer which is being used in microcontroller and embedded system to detect and recover from malfunction or software faults. So the main purpose of a watchdog timer is to ensure that the system would be operate reliably by monitoring the execution of the main program. So if the program hangs, or if it is crashes, or if it enters into an infinite loop, so the watchdog timer, okay, it can reset the microcontroller. Right, so it means that the error that comes from the infinite loop and so on, so they can restore again the operation. Alright, so in terms of brownout detection, so brownout detection in ATmega 328 is actually a safety features which is being used to monitor the supply voltage. So it means that if the voltage falls below a certain threshold that we have set, so the brownout detector will reset the microcontroller to prevent some erratic behaviors, some uncommon behavior caused by the insufficient voltage levels. So the function of watchdog timer and reset brownout detection is actually they wanted to make sure that the ATmega 328 can be operating continuously without any interference. Alright, so next we go to the program and data memory mapping in ATmega 328. So in the ATmega 328 controllers, so the memory is organized into main types lah. So you have program memory and also the data memory. Right, so the program memory, which is, we also call it flash memory. So the type of memory that they use is non-volatile memory. So it means that it retains the data even the power is being turned off. Alright, for example, if you program the code inside your ATmega 328, so it will remains, or it will retains even after you switch it off. Okay, you don't have to program it again, you don't have to flash your program again. Right, so the purpose of the program memory is actually to store the program or code, alright, that our microcontroller execute lah, as I just said before. So this is where your compile program, okay, is being uploaded. Right, when you do some program, for example, if you wanted to do some LED blinking, so the program will be uploaded into the program memory. Right, so that you don't have to upload again lah after you switch off the device. Alright, so the size of the program memory for ATmega 328, they have 32 kilobyte of flash memory, which they have reserved, okay, this 2 kilobyte for the bootloader. Alright, okay, next is the data memory. So data memory, they have 2 types of data memory. Okay, so inside the data memory, they have 2 types. The first type is the SRAM, or the static RAM. So basically what I have just explained it to you in the previous class. So static RAM is actually volatile memory. So it means that you loses that data when you turn off the device. Alright. So the purpose of the static RAM inside the data memory is used to, what do we call, storing variables, temporary data, and function call data during the execution of your program. Right, so for example, you have ultrasonic sensors, and then the data that you have, the distance data that you have from the ultrasonic sensors is saved inside the variables called distance. Okay, so the data inside the variable distance will be disappeared all right, after you switch off the device, because it is being stored inside the static RAM. All right. All right, so for Atmega 328, they have the total of 2 kilobyte of SRAM, okay? And then the next type of RAM that is being used in data memory is actually EEPROM lah, or it stands for electrically erasable programmable read-only memory. So this type of memory is non-volatile. It means that it will retain after you switch off the device. So the purpose of we call it the EEPRAM inside the data memory, it is used for storing data that must persist even when the microcontroller is the microcontroller is being powered off lah. For example, so if you wanted to save some configuration setting for your system, all right. So for the EEPROM for Atmega 328, they have a total of 1 kilobyte, all right. Okay, so basically the next part is actually regarding the registers, all right. So this is the general purpose working register, all right. So in Atmega 328, we call it general purpose working register. It is actually a set of fast, directly accessible storage locations which is used to perform operation in CPU lah. Right, so these registers are the integral, which is the main part, right, of the efficient execution or efficient operation inside your microcontroller or inside your CPU. All right. So these registers are actually will execute instructions, and it is used for temporary storage and data manipulation using program execution. Alright, so for Atmega 328, they have a total of 32. Okay, so 32 from R0 until R31. It means that they have 32 general purpose working registers, okay, which is labeled as R0 and R31. Alright, so each register is actually 8 bits in size, meaning that they can store 8-bit values lah. Alright, so they also refers to as byte-sized registers. Right, it means that 8-bit equals to 1 byte. Right, so the main purpose of the general purpose working register is actually to perform arithmetic. Okay, for example, you wanted to perform some mathematical process, plus, minus, divide, and so on. And then logic, okay, if you wanted to perform some conditional methods, okay, if else, and so on. And also some data manipulation operation. Right, so the next purpose of the register, general purpose working register, they also serve as operands for instruction like addition, subtraction, bitwise operation, and so more. And then the data from SRAM, okay, which is the main data memory, can be temporarily loaded. We can temporarily load it into these registers to be processed. All right, which makes them faster lah. If you wanted to get the data, we wanted to access data, because the GPWR ni, all right, it's so fast. Okay, it can make the program or the system or operation to become faster. Alright, so as you can see, this is the name of the registers for R0 until R15. Okay, so this is actually general purpose registers. So from R16 until R31, we call it higher registers. Okay, it means that they are commonly or usually used more frequently in arithmetic and logical operations. Right? Okay, so as you can see here, so some of these registers, they can also be used as a pointer registers. Okay, for example, R26 and R27, we call it X registers. So it is actually being used as 16-bit pointer, because one is 8-bit. If you combine those two, it will become 60-bit. Okay, 16-bit, it is used as a bit pointer, right? And then the next is R28 and R29. Okay, it can also be used as 16-bit pointer. So it is actually often used as an index addressing. Okay, so the last one is the Z registers, R30 and R31. It can also be used as a 16-bit pointer for indirect addressing. Right. So because all of these registers are located inside the CPU, so the access time are so much faster compared to data that is stored inside the SRAM or flash memory lah. So most of the instruction that is being operated, alright, in a single clock cycle, so making them very efficient if you wanted to execute very fast and real-time operation. Alright, so next is status register and also the stack point register. So in Atmega 328, both we call it SRAC and also SP. Okay, it plays crucial roles in program execution. Okay, so the main function is they help to manage the microcontroller operation by tracking the outcome of instruction, okay, and handling the stack of function calls, interrupt and return addresses. So that is the function of those two. Alright. Okay, the first part is the status registers. Right, so inside ATmega 328, the status register is actually an 8-bit register that holds the status flag, okay, of the microcontroller. So inside the microcontroller, they have some flags, okay, that hold some indications on the status of the process. All right. So these flags are updated based on the result of arithmetic, logic, or bit manipulation instructions. Right, so the status register is actually used to influence decision making in the program lah, such as branch condition, interrupt handling. Okay, so if you have active your interrupt, so the interrupt flag will be activated and so on. Right. So each bit in the status register, it represents a particular or its own functions. Right. So for example, as you can see here, C is actually a carry flag. So C is at bit number 0 of status register. Okay, so for C, for carry flag, okay, it will be set. It means that it will become 1 if the result of an arithmetic operation generates a carry out of the most significant bits. Okay, so for example, if you do some addition, if the sum of the addition exceeding the size of 8-bit, and then this C registers will become 1. Alright. So the next part is Z, which is 0 flag. Okay, so 0 flag is located at bit number 1 of SRAC. Okay, so this bit, this Z registers will be set, or it will become 1. Okay, if the result of an arithmetic or logic operation is 0. Okay, for example, if you wanted to do some equalization, so for example, is 8 equals to 8? It means that it is equals, so it will become 1. Okay. Alright, so if the result is 0, it will become 1 lah. Alright, so next is N. N is actually, we call it negative flag. Okay, negative flag is located at position 2 of your AVR status registers. Okay, so it will become set, or it will become 1 if the result of arithmetic operation is negative. Of course lah, it is negative flag. So if the operation is negative, it will become 1. Alright. So next is V. V is actually overflow flag. Okay, it is located at bit number 3. Right, so this we call it a register will become 1. Okay, or this flag will become 1 if there is some overflow in arithmetic operations. Okay, so it means that if you adding two positive number, suddenly it yields some negative result. So it means that the data has been overflow lah. So if there is overflow going on, so this flag will be set. It will become 1. Right. So next is S. So S is actually a sign flag. Okay, so the sign flag is located at location number 4, bit number 4 of the status registers. Okay, so it indicates the sign result of an operations. Okay, basically if you do some sign arithmetic operations, if you have sign results, okay, it will set. Okay, or it will become 1. H is actually the half carry flag. It is located at bit number 5 of status registers. Alright, so it will set if a carrier from 3-bit to 4-bit in an arithmetic operation lah. So it is actually very useful in binary coded decimal. Okay, so if there is some carrier from 3-bit or from bit 3 to bit 4, for example, if this is bit 3 and this is bit 4, so there is some carrier from 3 to 4, alright, H will become activated lah. So it means that it will become 1. Alright, so the next one is T. T is actually the transfer bit. Okay, so it is actually the general purpose bit lah, which is used for bit copy instruction, and I is actually global interrupt enable flag. So it means that if the interrupt is being enabled, so this I interrupt or I registers here will become 1. Next, we go to the stack pointer, SP register. So the stack pointer is actually a 16-bit register which is points to the current location in the stack. Okay, so what is stack? So the stack is actually used for storing temporary data such as return addresses, local variables, and register values during function calls and interrupt. So it actually operates in LIFO, okay, last in, first out order. So for example, some of the characteristic of the, we call it stack point, is actually stack point size. So the ATmega 32.8, the stack pointer is actually 16 bits wide. As you can see, they have two rows. The first row we have 8. The second row we have another 8. So the total is 16 bit. Okay. So even though the microcontroller has only 2 kilobyte of SRAM, so the lower portion of the stack is used for the SRAM memory. Right, so when the microcontroller starts, the SP points to the top of the SRAM, okay, the highest memory address, and grows downwards as the data is pushed into the stack. Right, so what is the role or what is the function of the stack pointer? So the first function of the stack pointer is actually for a function calls. So when you call a function, okay, later when you code your system, when you have a function, okay, when a function is called, the return address is stored on the stack. Okay, so the SP or the stack pointer is decremented to make space, okay, and when the function return, the SP is incremented to retrieve the return address. Right, so the second function is interrupts. So when some of the interrupts occurs, so the microcontroller will automatically push the current program counter into the stack, okay, allowing the system to return to its previous state after the interrupt is, we call it interrupt service routine, ISR, is completed. Right, so the next function is actually for the push or pop operations. Right, so the stack pointer is being also used during push and pop operation, which is usually stores and retrieve some register value to and from the stack. All right. So for the summary, okay, so for the status registers, okay, the function or the main conclusion is that it is used to monitor the result of arithmetic and logic operation with flag like 0, carry, overload, and also it is used to, we call it monitor the interrupt condition. Alright, so next is stack pointer. Stack pointer, it is used to track the top of the stack in SRAM, okay, which is used to store return addresses, register values, and local variables during function calls and also interrupts. So that is what status register and also the stack pointer is all about. Right, so you can also refer to the slides on all of the register summary, so you don't have to understand each and every address of the registers. Okay, only the important one is the one that I have explained. Right, so this is some of the register summary. Okay, we have, for example, we have timer counter here. Okay, we have some of the other registers here. All right, because there are lots of them, so I cannot explain every single of them. Right, but the important things that you have to know is just the stack and also the status registers. Right, so next is how you wanted to program the Atmega 328. Okay, so they have 4 types or 4 procedures or 4 ways for you to program the memories or for you to program inside the Atmega 328. The first one is self-programming using any physical link. Okay, right? So for the self-programming, you can just program through any interface, for example, SPI or TWI interface, all right? And then it is actually 100% secure, which is very, very encrypted remote updates. All right, so the next one is you can do some parallel programming. Okay, so the parallel programming in Atmega 328 is actually a method where you can program the microcontroller by directly access its internal memory and register through multiple data and control lines. So previously you have learned about Harvard architectures inside Atmega 328. They have data lines and also control lines. Okay, so you directly you directly access into that line in order for you to program it parallelly, right? So this parallel programming is actually one of the fastest way for you to download, and it is actually compatible with any major programmers lah, right? Alright, so the third one is the in-system programming. So it is actually native 2-wire PDI, right, or 3-wire SPI interface. Okay, so for it is actually like serial communication. Okay, right, it is a quick update in the field and it is actually easy to use. And the last one is actually JTAG. Alright, so JTAG is actually one of the it is actually using serial communication interface lah. Alright, so we call it the protocol that they use is IEEE 1149.1 compliant interface, and it can program flash, EEPROM, fuses, and log bit. Right, so it is also support on chip debugging, and it also have the boundary scan PCB test. Alright, so as you can see from all of the methods shows here, as you can see there are 2 stars and 1 stars. So 1 stars, it actually require programmer hardware that supports them. And then for 2-star, it is actually programmed with the help of resident bootloaders. So the bootloader must be pre-programmed in the boot flash section. So basically for Arduino, they already have their own bootloader, so you can just program by using Arduino IDE. Alright, So this is the example of the ATmega 328 pin out. Okay, so you have some port A. Where is port A? Okay, you don't have port A, you have port B. Okay, I'm just joking, you don't have port A. You have port B. Alright, you have port C. And you also have port D. Alright, so you also have VCC, which is the voltage supply, ground, A reference, analog reference, okay, analog VCCs. Okay, alright. So this is the pin out description for ATmega 328. Right, so for VCC and ground, so VCC is actually the digital supply voltage for ATmega 328. So for ATmega 328, okay, the supported voltage for operation is from 2.7 to 5.5 volts, right? And then you also have XTAL1 and XTAL2. Okay, so this is actually connected to oscillator for clock signal generation. So for clock, it is important for you to have a clock in your microcontroller because you wanted to measure, we call it the sample rate, okay, the rates where we call it the communication, the serial data, the baud rate, and so on. Alright, so next is the reset. So reset is actually the function is to generation for reset to set all input output to the initial value. So if you wanted to reset to initial values, you have to use the reset button or reset pins, right? Next is AVCC, which is a supply voltage pin for ADC. So in order for you to work with analog digital converter, you need to have we call it a reference voltage. So the reference voltage is actually connected to here lah. Alright, and then next is AREF, external analog reference pin for ADC. So it is actually which is used for we call it the reference voltage or reference analog pin for ADC. And then you also have three different ports: ports B, port C, and port D. It is actually 8-bit bidirectional digital input output port and can be programmed to serve any functions that is being set inside the ATmega 328, because some of the ports, they can only serve as specific functions. Alright, so this is some of the system applications. So for example, you wanted to connect some of the devices to ISP connectors. This one is for RS232 for programming, for serial communication, and so on. So this is the ATmega 328. Right, so next is ATmega 328 programming tool. Okay, so you can, for ATmega 328, you can use Atmel Studio. So it is actually the front end for all AVR tools, alright? And then it is actually free. Okay, you don't have to pay anything for that. Right, and then next is the starter kits and evaluation boards. Okay, so it can be very cheap, alright, from 19 USD. And then the last one is on-chip debuggers and emulators. So it can go from $299. So this is Atmel Studios. This is Arduino evaluation box, and this is Atmel ICE debugger. Right. So next we go to the instruction set. So actually the instruction set, it is being used in assembly language. So you have used this instruction set inside microcontroller or inside micro P subject previously. Right. So for this subject, we are not using any instruction set. So this is just some of the refreshment for you. So the refresh of the macro P course. Right, so next is Arduino. Okay, so the main thing that we learn in this subject is actually we learn about Arduino. So how to code Arduino, how Arduino is all about, and so on. Right, so introduction to Arduino. So Arduino is actually an open source hardware platform based on Atmel AVR 8-bit microcontroller and a C++ based IDE. So basically, the chipset which is being used in Arduino, most of them is actually from Atmel, right? And then in order for you to program the Arduino, so basically, usually people are coding it by using C++ based IDE lah. So basically, we are using the Arduino IDE, right? So the Arduino is actually based on ATmega 328, which is 8-bit. So the one that we have learned previously, okay, right? They have 32K, 6-channel 10-bit ADC, PWM, SQAC, SPI. So the similar chip that we have learned in the previous or earlier part of this chapter. Right. So what is the good thing about Arduino? Okay, so the power is in the standard board design. So the board that the Arduino use is very standard, and then the wiring language, which is being very easy for us to understand. The open source, you don't have to pay anything. All right, after you buy the hardware, you don't have to pay anything because it is open source. All right, they have a very large community. Lots of people is being using Arduino, so you have lots of example, lots of exposures, lots of project, and the last part is it is not expensive. Right, so that is what good about Arduino. Right, so the philosophy of Arduino. So Arduino is actually can mean three things. Okay, either it is actually a physical piece of hardware, so this is Arduino Mega, or either it is a programming environment, so this is Arduino IDE, or it can be a community and philosophy, which is Arduino Forum. So basically anything or any problem regarding Arduino is being discussed inside the Arduino community. All right. So this is some of the family of the Arduino. You have Arduino Nano 33 IoT, you have Arduino Micro, Arduino Uno, Arduino Due, Arduino Mega 2560s, and Arduino Leonardo. Right, so for small sizes, you can use Arduino Nano or Arduino Micro. Right, so for if you have simple applications, right, we call it you can use Arduino Uno because it doesn't have that much I/O pins. Right, so if your application requires, we call it lots of applications, lots of I/O, so you can use Arduino Mega. So if your application requires you to use a very high speed processor, you can use Arduino Due, okay, Arduino Due, because it is used ARM based processors. All right, so this is the example of Arduino family. Right, so Arduino family is being categorized based on system voltage. So some Arduino it can works in 3.3 volts, and some Arduino can works in 5 volts. Right, they also categorize in terms of the clock speed, which is the speed of the processors. Right, some parts is 16 megahertz, some processors is 8 megahertz, and so on. All right, so as you can see here, Arduino Due here is 84 megahertz, which is very fast compared to the other types of Arduino. All right, so next is it is also being categorized in terms of digital I/O pins. Right, either you have 14s, you have 20, or you have 54. Even you can have like up to 54 pins, right? And then in terms of the number of analog inputs, the number of pins that supports PWM, the number of UR is actually the universal asynchronous receiver or transmitters. It is actually a hardware communication protocols that is facilitates the serial communication between each devices, right? So in terms of programming interface, you can use some USBs or FTDI, all right? And the cost is, the most expensive one is actually the Arduino Mega lah, 58 USD. So this is the prices of Arduino, all right? So which is actually not that expensive compared to the other parts or other types of microcontroller. All right, so for this cost, basically we are using Arduino Uno R3, right? So this Arduino is actually based on Atmega 328, so it can operate good in 5 volts. All right, so you can switch on, or you can operate the Arduino when connected to the input voltage from 7 to 12 volts. All right, and then the limits that the input voltage can support, which is from 6 to 20 volts. So it means that if you have 22 volts, your Arduino will be burned. All right. And then for this Arduino Uno, they have a total of 14 digital pins, which is 6 of them. It will produce PWM output, where you can use it to control the motor, or where you can use it to control the brightness of the bulb, and so on. So in terms of analog input pins, where we usually use the sensors to connect it to the analog input pin, we have 6 pins. All right, so DC current that it can produce is 40 milliamp. All right, so for 3.3 volt pins, it can produce up until 50 milliamp current. Right, so in terms of flash memory, we have 32 kilobyte, okay, which 0.5 kilobytes of 32 kilobyte here, it is used by the bootloaders. Right, so they have 2 kilobyte of SRAM, 1 kilobyte of EEPROM, and the clock speed of 16 megahertz. So this is the layout of the Arduino. All right, so you have this is the USB-B port, which is being used to connect from Arduino to the computers. You have crystal oscillator here, you have voltage regulator. You have a barrel jack where you can connect your input voltage from 7 to 12 volts. You have reset button here. And then you also have ICSP, in-circuit serial programming. You have I2C protocol here, LEDs. This is the MISO-MOSI, which is some of the SPI protocol, right? And then you have interrupt pins here. transfer, receive pins for serial communications. So this one, you also have another SPI serial peripheral interface here. You have analog pin, you have I2C here, and then you have some of the voltage interface. You have ground, you have 3.3, 5 volts, and so on. Right, so this is the Arduino Uno board layout that you will use in this course. Right, so this is actually the circuit lah, the breakdown circuit. So this is the Atmel 32.8, and this is the interface of the circuit inside Arduino. Right, so this is the output, similar, right, to what you have seen in the previous slide, where you have pin port B, port C, and port D. Okay, because it is Atmega 328, so it is just the same based on the previous slide. But what differs here is that what is actually the connections from this PC5? It is being connected to Arduino analog input 5. Alright, so for example, port B5 it is connected to digital pin 13 of Arduino, and so on. So you can refer to this documentation in order for you to map the connection from Atmega 328 to Arduino Uno pin out. Right? So next is Arduino Shield. So because of the limitations of Arduino, the size is small and so on, they cannot fit everything inside one module. For example, wireless, relay, and so on. So in order to do that, we are using Shield. So Shield is actually connected to the I/O board to extend the functionality of Arduino, right? So Shield is actually come with library to make it easier for them to be used, right? We have lots of shields available, right? And you can also make your own shield. Okay, so basically the shield is being stacked up together to save more space and to make sure that it is being more stackable. Right, so this is the example of Arduino Shield. You have, for example, Ethernet Shield, Relay Shield, Motor Shield, LCD Shield, GSM, joystick, smoke detector, capacitive. You can also have NFC, GPS logger, ESP8266, Bluetooth, CAN bus, wireless, sensors, or prototyping shields. Right, so lots of shields available and many more. Okay? Alright, so what I want you to do now is, alright, you have to do some hands-on exercises. Okay, so if you didn't install arduino.cc yet, so you have to install, okay, because we will use this software throughout this course. Alright, download and install Arduino IDE, get Arduino board and USB cable, connect the board, install the driver, launch the Arduino IDE, and open the Blink example. Alright, so this is the most basic one. So if you haven't used Arduino before, so this is the first example that you should use. Alright, select board type, select your serial port, upload the program, and you can run. Alright, so this is some of the setting up that you have to do in order for you to continue doing this course. Right, you have to install the Arduino software. Maybe you have to buy very cheap Arduino Uno, and then you can try by yourself. Right, because for this course, the practical is very, very important. Okay, so in order for you to success doing this course. Alright guys, so thank you very much. Alright, sorry for missing this class this week. Alright, so we will meet again next week as usual. Alright, so thank you very much. Assalamualaikum and have a good day everyone.